In the autumn of 1962, on a hillside in the shadow of Mount St. Helens, a young botanist named Arthur Berkeley knelt beside a small, twisted tree that most foresters would have walked straight past. It was not tall, it was not beautiful. Its bark peeled in reddish flakes, and its needles, if crushed and eaten, could kill a grown man within hours. For 3,000 years, every culture that had ever lived beside this tree had learned to fear it. And yet Berkeley filled his sample bags with its bark and needles anyway, because he had been sent by the United States government on one of the strangest hunts in the history of science, a hunt for a cure hidden somewhere among the plants of the earth. He had no way of knowing that the tree he had just stripped bare would one day save the lives of millions of people who had never even heard its name. He had stumbled, almost by accident, onto one of the most peculiar secrets in the natural world, that the same substance capable of stopping a heart could also be trained to stop cancer. Long before Berkeley ever set foot on that hillside, this tree had already been feared, worshipped, and weaponized across half the world. It is called the yew, and it belongs to a species so ancient that some living specimens in the churchyards of Britain and Ireland are believed to predate Christianity itself, quietly outliving empires, plagues, and the very religions built in their shade. The yew does not behave like other trees. Its low branches, when they touch the earth, can take root and rise again as new trunks, so that a single yew can, in a sense, keep being reborn out of its own body for thousands of years. Ancient peoples noticed this. They could not explain it, but they felt its weight, and so across Celtic lands the yew became bound up with death and resurrection at once, a tree that seemed to defy the very cycle it was supposed to obey. In the old Celtic Ogham alphabet, the yew held a sacred letter of its own, tied to the turning of winter, to endings that were somehow also beginnings. But reverence for the yew was never separated from dread, because everything about it, apart from the soft red flesh of its berries, is lethally poisonous. Roman writers recorded that certain conquered warriors chose to end their own lives with yew poison rather than surrender to Rome's legions, a detail almost too grim to imagine but repeated across ancient accounts. Farmers learned never to let their animals graze near it. Archers, in a darker use of the same knowledge, are said to have coated arrow tips with crushed yew seed to guarantee that even a shallow wound would prove fatal. On hot days, some observers claimed the tree released strange vapors that could cloud the mind of anyone who lingered too long beneath its branches, feeding centuries of folklore about the yew as a doorway between the world of the living and whatever lay beyond it. And then there's the question that has puzzled historians for generations: the true reason so many yew trees stand today inside the walls of English and Welsh churchyards. One theory holds that the trees were planted deliberately to keep grazing cattle away from consecrated ground, since livestock generally know to avoid the poisonous leaves. Another theory, more haunting, suggests that these groves were sacred to pre-Christian peoples long before a single stone church existed, and that when missionaries arrived they built their new houses of worship directly on top of the old pagan sites, absorbing the yew's mystery into their own faith rather than fighting it. Under the new religion, the yew came to symbolize the resurrection of Christ, its evergreen branches carried into churches on Palm Sunday in places where actual palms could never grow. The tree that had once stood for the old gods now stood, just as comfortably, for the new one. Few plants in the natural world have managed to switch allegiances between two entirely different spiritual worlds without ever changing a single leaf. Yet the yew's most consequential role in human history had nothing to do with religion at all. It had to do with war. The wood of the yew, dense enough to sink in water and possessing a rare natural spring in its grain, made it the finest bow, making material available to medieval Europe. English longbows cut from yew became the terrifying centerpiece of English military power during the 100 Years' War, capable of punching arrows through armor at distances that seemed almost supernatural to the enemies who faced them on the fields of France. The demand for good yew wood grew so intense that England was forced to import it by the shipload from across the continent, so much so that some historians argue the trade nearly stripped mainland Europe's forests of mature yew trees, a slow-motion ecological cost paid centuries before anyone had a word for ecology. In Scotland, tradition holds that Robert the Bruce ordered boughs cut from the sacred yews of Ardchatton Priory, wood that some say was carried into the decisive Scottish victory at Bannockburn in 1314. Whether or not every detail of that story survives close historical scrutiny, the underlying truth does not need embellishing. A poisonous tree, feared in every village that grew beside it, had somehow also become the deciding weapon of European warfare for more than 2 centuries. For all of this fear and folklore and firepower, nobody in the ancient or medieval world seems to have imagined that the yew's deadly chemistry might one day be turned toward healing rather than destruction. That transformation belonged to the 20th century, and it began not with a search for medicine at all, but with a Cold War-era gamble by the United States government. Between 1960 and 1981, the National Cancer Institute and the Department of Agriculture ran a screening program so vast it is almost difficult to comprehend, testing well over 100,000 extracts pulled from roughly 15,000 plant species, hunting blindly through nature's chemistry for anything that might slow or stop cancer's advance. It was into this program that Arthur Berkeley's yew bark samples disappeared, one anonymous entry among tens of thousands, sent off for testing with no particular reason to expect they would matter more than any other sample on the shelf. 2 years passed before the answer came back. At the Research Triangle Institute in North Carolina, chemists Monroe and Mansukh Wani discovered that extracts from the Pacific yew's bark were remarkably effective at killing cancer cells in laboratory cultures, a result strong enough to make them keep digging. By 1967, they had isolated the specific compound responsible, and Wall gave it a name drawn straight from the tree itself, Taxol, after the genus Taxus. It would take until 1971 for the pair to finally publish the molecule's full chemical structure, a shape so strange and complicated that other chemists initially doubted anyone would ever be able to manufacture it artificially. And still, for years afterward, the discovery sat largely unnoticed, a promising compound trapped in the slow, uncertain gears of scientific bureaucracy, its true importance still hidden even from the people who had found it. The turning point came in 1979, when a researcher named Susan Horwitz at the Albert Einstein College of Medicine set out to understand exactly how Taxol was killing cancer cells in the first place. What she found surprised even seasoned cancer researchers. Every other cancer drug known at the time worked by preventing a cell's internal skeleton, its microtubules, from assembling at all, starving the dividing cell of the scaffolding it needed to split in two. Taxol did something almost the opposite. It locked those microtubules in place once they had already formed, freezing the cell's internal machinery so rigidly that it could no longer divide, trapping the cancer cell in a kind of paralysis until it died. No one had ever seen a natural compound behave quite this way before. It was not simply a new drug. It was an entirely new weapon against a disease that had outmaneuvered nearly everything medicine had thrown at it. But there was a brutal problem waiting behind this breakthrough, one that would nearly strangle the discovery in its crib. The Pacific yew grows painfully slowly, tucked as an unassuming understory tree deep within old-growth forests of the American Pacific Northwest, and Taxol exists in its bark in vanishingly small concentrations. Producing enough of the drug for expanding clinical trials required staggering quantities of bark, and bark cannot be harvested without killing the tree. Some estimates from the period suggested that roughly 10,000 kilograms of bark were needed to yield a single kilogram of usable compound, meaning thousands of mature, centuries-old trees were being felled across the region simply to keep research alive. Environmental groups sounded the alarm, warning that a promising cancer treatment was on a collision course with the very forests it depended on, an ecological crisis wrapped inside a medical miracle. For a moment, it looked as though the cure discovered in that bark might have to be abandoned for lack of a way to obtain it, without destroying an entire ecosystem in the process. The rescue came, fittingly, from another part of the same tree and from another continent entirely. In 1981, French chemist Pierre Potier identified a related compound hiding in the needles of the common European yew, a molecule structurally close enough to Taxol that it might serve as a starting point for building the drug artificially in a laboratory rather than stripping it from ancient bark. Unlike bark, needles can be trimmed from a living tree again and again without killing it. offering a renewable source that no forest needed to die for. By the late 1980s, chemists including Potier's collaborator Andrew Green and separately the American chemist Robert Holton had each worked out efficient laboratory routes to convert this needle-derived precursor into full, genuine Taxol, a process now known as semi-synthesis. It was, in its quiet way, one of the great unsung triumphs of applied chemistry in the 20th century, an elegant solution that let nature do most of the difficult work while humans supplied only the final few careful steps. Within a few years, the destructive harvesting of Pacific yew bark was phased out almost entirely, and a drug once threatening to vanish before it could save a single life became something the pharmaceutical industry could reliably produce at scale. In December of 1992, the United States Food and Drug Administration approved Taxol, now known by its generic name Paclitaxel, for the treatment of ovarian cancer. Breast cancer approval followed in 1994, and lung cancer treatment in 1999. Clinical studies in the years that followed found that roughly 30% of patients with advanced ovarian cancer responded to the drug, a number that might sound modest until you remember how few options those same patients had possessed only a decade earlier. Today, Paclitaxel and its chemical relatives sit among the most widely used chemotherapy agents in the entire world, prescribed to treat breast, ovarian, and lung cancers as well as Kaposi's sarcoma, deployed in hospitals on every continent, entirely disconnected in most patients' minds from the small, gnarled, poisonous tree that once stood watch over English churchyards and armed medieval bowmen for war. It is worth being honest about the limits of the story too, because Paclitaxel is not a gentle drug, and it carries real side effects including nerve damage and suppressed immunity that oncologists must carefully weigh against its benefits, a genuine medical tool with genuine costs rather than a miracle without consequence. What makes this story almost impossible to shake once you have heard it is not simply that a poison became a medicine. Plenty of toxins have found narrow medical uses throughout history. What makes it remarkable is the sheer scale of transformation and the centuries of raw human intuition it took to even get close to the truth. Celtic druids who wove yew boughs into rites of death and rebirth were not so far from something real, even if they had no language for cell division or molecular biology. Medieval clansmen who swore by the yew's protective power, and archers who understood its lethal precision better than any chemist of their age, were interacting daily with a plant whose deepest secret would not be unlocked for another 600 years. Every culture that feared this tree was, in its own way, correctly reading its danger, and none of them could have imagined that the very same danger, extracted, purified, and gently reshaped by human hands, would one day be injected into human veins specifically because it could stop a cell from dividing. There is something quietly humbling in that. For thousands of years the yew stood in graveyards as a symbol of the boundary between life and death, and it turns out that boundary was never just a metaphor. Inside its bark and needles sat a real chemical hinge on that very threshold, one capable of ending a life in the wrong dose, or extending one in the right dose, all along, waiting patiently inside a tree that most people were taught, correctly, to avoid touching. The next time you happen to pass an old, dark, twisted yew standing sentinel in some ancient churchyard, it may be worth pausing for a moment, because the tree your ancestors feared as a gateway to death has, in one of history's quieter miracles, become one of medicine's most trusted weapons for holding death back.